Chapter 4: Design and Innovation for a Circular Economy. We live in a consumption-based society, and most products today are designed for fast replacement. Just think of fashion or electronic devices. Some products are even designed for planned obsolescence to make us consume even more. The circular economy clearly requires that circularity is considered already in the design phase. But what does circular design then imply? In line with the overall definition of circular economy, in Catch E we have developed this definition of design for the circular economy. Design for the circular economy is the design and development of products, services, and product service systems that replaces the conventional end-of-life concept by closing, slowing, and narrowing the resource flows in production, distribution, and consumption processes. It is enabled by innovation and novel business and organizational models, and aims to accomplish sustainable development through supporting of ecosystem functioning and human well-being, and through responsible production and consumption. Thus, the Catch E project proposes to adopt an integrative approach to the concept and practice of design for the circular economy. The right combinations of product and service design strategies support circular economy by closing resource flows through recycling. The loop between post-use and production is closed, resulting in a circular flow of resources. Slowing resource flows where the utilization period of products is extended or intensified, resulting in a slowdown of the flow of resources. And finally, narrowing flows by using fewer resources per product or service unit. What we talk about in practice is to reduce, reuse, and recycle, but also about repair, refurbish, remanufacture, recover energy, and other approaches, including related services. Linked to circular design, any business will have to consider new or adapted business models, for example, to extend the product lifetime through services. Let's take some examples. Product design approaches to slow loops means designing for durability, for example, by designing long-life products, fostering strong product-user relationships, inviting users to keep their products for a longer time, producing resistant, easy to maintain and repairable products, or to use modularity, allowing for the upgrading and adaptation of products. For example, like the German Curl office chair, which has a modular design that facilitates repair and aesthetical upgrading. Product design approaches to closed loops is to design for recycling. For example, to develop products in such a way that the materials can be continuously and safely recycled into new materials and products. To use safe and healthy materials for those products that are consumed or worn during use, and thus create food for the natural systems. To make it easy to dis- and reassemble products. For example, Interface in Australia has partnered with the Zoological Society of London to buy discarded fishing nets from some of the poorest communities in the world, in this case the Philippines and Cameroon. The nets are recycled into new yarn for carpet tiles by Aquafil. The benefits are that we have fewer ghost nets in the ocean, use less virgin materials, and a new source of income for the community is created. Finally, product design approaches to narrow loops means designing for resource conservation by using preventive approach in which products and services are designed so that the use of resources is minimized in the whole life cycle. In addition to quantity, it also means choosing more sustainable materials and energy sources when designing a product or a service. An example is the reduced flow faucets. Nowadays, there are much better solutions than the ones shown in the picture. Reduced flow faucets can save a lot of water and money to consumers. This is an example where design influences resource conservation in the use phase. Design for circular economy is further unfolded in the Catch E design and development module. How do you know whether or when a product or a solution is circular? For example, is a product more circular because it has a longer lifetime, even if it ends up in a landfill? The answer is not simple, but it can be yes, if the longer lifetime will save a large amount of resources. In any case, you will have to make an assessment, and the Catch E module on life cycle perspective presents methods for evaluation. From a material resource perspective, the Ellen MacArthur Foundation has defined a linear versus a circular product. The 100% linear product is manufactured only using virgin feedstock, and it ends up in a landfill. The 100% circular product contains no virgin feedstock and is completely collected for reuse or recycling. But the 100% circular product is theoretical, since there will always be losses related to collection, reuse, and recycling. Assignment. Design goes beyond the product. Reflect on a product of your own choice and the need it fulfills. Think of a sustainable, circular solution to address that need. Does it involve designing a totally different product, a service, or maybe a combination? For further information and complete references, please consult the full text of the module.